Good morning, everybody, from Portland, Oregon. I'm Randy Hopkins. Welcome to TechKrunch at Komprise. This is where we bite into, aka the TechKrunch name, topics and questions from you and demonstrate functionality or use cases that you want to know about. We call it TechKrunch because we take a technical approach, but we show you how it's done with live demos. So today we're going to be focusing on migration and the performance of migration. Our migration is used by tons of customers and is becoming an even more important use case as they are migrating NAS data from an old NAS to a new NAS, or NAS from on-prem to a cloud NAS and things like that. So whenever we work on a migration project, it is always a symptom of a bigger initiative. So we're going to be focusing strictly on the performance of NFS and SMB and how we scale out. Before migration ever starts, we always get questions about how much data do I have? What percentage of my data is big files and small files? Can I move or tier my cold data before I migrate? And can you help us do that? How much hot data do I have? Can I tier it, as I said earlier, while always making it transparent to the applications? And the big question that we're going to be tackling today is how the heck does Komprise scale to get that massive performance that reduces migration, in many cases from 4 weeks of migration with things like robocopy or whatever, down to a single day? And with SMB, how do we get it from running 7 days of runtime down to 1 day? So what we're seeing is anywhere from 25x performance or 7x performance. So let's go to the next slide, see the agenda, and my very special guest, Chris Dearden. So Chris Dearden, we're going to show the audience who we are and tip our cup of coffee. By the way, Chris Dearden's over near London, England. So I don't have tea today. He probably does. Oh, you have water. There you go.
Water.
So hey, say hello, Chris. Say hello to the people on the audience.
Good morning, good afternoon, everybody. Looking forward to showing you some of the nuts and bolts behind the migration.
Cool. Yes. Hey, thanks for helping us out today. Appreciate it.
No problem.
What we're going to be focusing on is migration and Komprise. We're going to show you a little bit about the analytics first, how to set up and migrate with Komprise, and then walk through how you improve the performance of the migration itself. So I'm going to pass this over to Chris. He's going to show you what the environment looks like, where we fit in that environment, and then we're going to go right into the demo. Thank you, Chris.
Great. Thanks, Randy. So the diagram we've got on screen at the moment illustrates a fairly typical kind of environment that we'll be doing a migration in. On the left-hand side, we have our old NAS. Maybe it's reaching its end of life, not performing quite as well as it could do. And then on the right-hand side, we have our shiny new NAS. Perhaps it's an all-flash one. Maybe it's a little bit smaller than the old one because we don't necessarily need the space. And in the middle, we have the Komprise grid. So this is just software. It's just some VMs that have been deployed, depending on the protocols we have, either Windows ones or some Linux ones. So we're not needing to bring in any particular boxes or hardware to be able to do this migration.
And as a reminder, also that NAS on the right can be on-prem NAS, or it could be NAS in the cloud as well.
Absolutely. The Komprise grid is going to talk to the director. This is our control plane. It's where you do all the work from, and it's just pretty much a website that you log into. And that's where we're going to jump across to now. So this is the Komprise director, and we added in our old NAS, and I've also got the new NAS added in. So here it is. I've got a share on this that has been enabled, and the Komprise has crawled that share and allowed us to analyze and take a look at what the hot and cold data looks like. We can dive a little bit further into that and see the types of data on it. So we're looking for, say, the actual data types by extension. We can look at the distribution of file sizes. This is going to be quite important when it comes to estimating how effective we're going to be. The smaller file sizes are always going to have a slightly larger overhead per file. We can also look at things like the ownership details of the files and see, is there data we don't need to migrate? Perhaps there's data we can actually clear out before we migrate.
And mind you, folks, that this analysis, knowing a little bit about your data, is part of the migration engine. It comes bundled together. So looking at this donut, you can see about half of the data hasn't been accessed in more than a year overall, and roughly 25% of it's probably been active in the last 6 months. And this is part of our migration package.
Absolutely. And what we could do, we could move some of that to a different tier of storage. But in this particular instance, we're going to migrate the lot. So we go across to our migration screen. And I've got a couple of other migrations that are running, but we're going to start a fresh one. So I go into select my source. So my source is going to be the old NAS and the old share on the old NAS. And we want to take the entire share across. We'll then select where we want that data to go to, and that's going to be the new NAS and the new share on the new NAS. We give it a name. We can set the sorts of things we're interested in, perhaps to refresh all the permissions. Permissions tend to get a little bit messed up over time, so we can disable those if we need to. And the same thing for access time. Now, not all platforms track access time as effectively, so you might just disable the access time tracking in certain circumstances.
We got a real-time question here, so I figured I'll throw it out there. What you're doing now, can this also be done? What you're doing now, can this also be done via API?
We do have a REST API where we can create and manipulate migration, particularly when it comes to large numbers. If we've got to form a final iteration on a large number of migrations, then scripting is most definitely the way to go on that.
Got it. There must be some NetApp folks on the line too, because there was a question: what happens when we migrate F-policy files? What happens to those files if we're migrating over to a different vendor, for example? So
if we have Komprise dynamic links that are based on F-policy, or ones that are based on Symlink that need to be converted to F-policy, so maybe we're moving to a NetApp and it's a Komprise managed share, then Komprise will take care of translating the traditional Symlink into an F-policy link. So it's something that's handled natively by Komprise. So that share is going to run through. It'll be a series of iterations. Each one should be getting smaller than the last until you understand that daily churn and you're able to do your failover. So that's the basics of how the migration engine works and how you set one up. Let's take a look at how we can make it a little bit faster. So there's a few sort of ideas here, and whilst they seem quite high level, there's definitely some interesting stuff underneath that. So the first one is migrate less data. Seems obvious, doesn't it? If you want your migration to go faster, don't migrate as much. But by moving out the cold data, you're going to do that. You're going to potentially reduce the volume of data you need to migrate by 70% or even more, just by moving that data that's not been touched for a year out to a different platform. The next way to improve your speed is around do lots of things at once, multi-level parallelism. The Komprise grid allows us to scale out the number of data moving threads, whether that's the number of threads used for SMB or the number of threads used for NFS. You can add as many proxies or observers within that Komprise grid as you need to without any effect on the licensing requirements. We also try to be efficient at the protocol level. So for NFS particularly, we've built our own NFS client, which allows us to be particularly efficient when we're migrating across links that have latency. So if we are migrating across a WAN, then doing it over NFS is most definitely the swiftest way at the moment.
Yeah, that's really efficient in eliminating a lot of unnecessary chatter in a big way, especially across WANs, for sure.
Yeah.
Yep.
Absolutely.
Yeah.
And the last one is start early. So in days gone by, migrations were a very frustrating weekend where you had your failover weekend and you had to get all of your iterations complete in that weekend, potentially from start to finish. And if you couldn't do it, then it was going to be a pretty disappointing weekend. Whereas with Komprise, you can set those iterations running long in advance so that you start to get them the stabilization and what the daily churn of your storage is going to be, so you can predict exactly how long that outage window needs to be. So you minimize the outage window, which effectively what the customers are going to be seeing as how long did my migration take. They don't care that you've been running iterations for a couple of weeks beforehand, because that doesn't affect them. They should be able to access their storage for the length of that migration run.
There's another question. This one, I think we're going to show them how to do it. There was a question about how do we add those proxies and observers to an environment that's already running. So do you think we can pop back over to that UI and show them where that's?
We certainly can.
By the way, our system was designed by a few people that have PhDs in scale-out computing, so it's a highly scalable environment. So Chris is going to show you, he's going to pop over to the UI and show you how you download and install additional data movers, if you will. We call observers.
So for the observers, it's very straightforward. You can download the observer appliance file if you're running within VMware, boot that appliance up, point it at the director, you now have a new observer. And you can do exactly the same with the proxies. So the proxies are just a standard Windows server to which you install a tiny little MSI file, so like 4 meg download, and then point at that proxy in elastically, and you can remove it elastically. You can do this whilst a migration run is going if you really wanted to. You can pull these out as templates and say, deploy me another 3 or 4 of these and add them in, and then trash them afterwards. Absolutely fine.
Yeah, and you're going to get some pretty decent linear performance if you go from 2 observers and move it up to 6 observers, for example. You're going to get massively more performance out of your migration. So. Yeah,
we should be able to scale the grid such that Komprise is not going to be the rate limiting step. The rate limiting step is going to be network, or it's going to be someone else's storage. So a couple of considerations around when you're choosing a tool that's going to do migration. You want to make sure that not only is it preserving the integrity of the file, which is pretty much table stakes. You want MD5 checks on every file that goes across because you want the same file to arrive as the one that's sent. But you want to make sure that you're able to migrate all of your access control lists and all of your attributes. And that includes some of the extended attributes, particularly if you're using NFS v4, which has quite a range of attributes depending on the underlying storage. You want it to be able to be automated, as the question came in earlier, that if you're going to do something more than a couple of times, you really want to be trying to automate it, and that transient errors shouldn't cause you to have to restart your migration. That's that shouldn't be a showstopper. Transient errors should be handled and natively retried on the subsequent iteration, and being able to customize some of the gap between iterations. So you're typically going to want these to try and run at night when there is, or the period when there is low use on the system. But remember that people tend to back up their systems at night. So you can use the gaps between iterations to be able to control that as necessary.
Let's wrap this baby up here. There are some resources on our website. We do post these. So if you want to go and find the library on the website, just search for TechKrunch and you'll find plenty of information. So next up here is, just want to give you an idea of what we're going to be talking about next time. We're going to be covering writing to worm compliant targets. So if you want to write to a worm device, and then we're going to follow that up with leveraging deep analytics with operations. But before those two, we're going to do a deep dive on how Komprise uses Unix and Windows symbolic links and symlinks to tier data to object store, and then be able to access that data, and how to also how to demonstrate that your applications will work with symbolic links. So that's it for today. Till next time, from Chris, Dearden, and myself, thank you so much. Bye for now.